Hey everybody, it's Monty and it's Algebra 2 SPV. And here we are, week 33, May 17th to the 21st, so middle of May. And we want to check in to see how we're doing. Okay, so Algebra 2, here's our teams page. Okay, and we're basically halfway through. Okay, we started March 1st, March, so we went March and April. Now we got May and June. Remember, you can always go to the Teams page to see me post the weekly video. You have the stream channel up here where you can see the videos. Or you can just go to our Blackboard shell. Alright, so we find the internet, and then we find our digital tools, and then we find our there it is. Okay, we find our clever button, then we find our Blackboard, then we find our shell. Okay, so let's go find Algebra 2B with Monty. Okay, in the announcements, you can find all the videos posted all the way along. The neat thing about this is once you find the one you're in, then you can go find the other videos that you need. Okay, now we're done with trigonometry and we're done with radical functions, and we're into exponents and logarithms. Okay, I think we've done enough with the exponents and exponents. Let's make sure we actually use a logarithm a couple of times. So we're going to go to there. So let's just check our coursework. We're not ready for periodic functions yet, so we're going to click inverting functions, and then we're in topic 2, exponents and logarithms, and we did the linear and exponential. We did properties of exponents. Now we're into logarithmic functions, and logarithmic functions. Boom. Okay, and the last couple of weeks we learned to translate from one form to the another, and then we graphed them. That was a little bit of last week. Now we need to apply them. Okay, applying a logarithm. What does a logarithm do for us to help us solve problems? All right, and cheat sheet. Let's go to announcements, and our cheat sheet right there. Boom. Okay, should open up in a separate page. We did our growth and decay functions, and right now we're living here, and then we're going to use them to solve. All right, so let's get started. Now again, we're kind of all over the board. Everybody has moved beyond here, and a few of you are in the exponents and the graphing, and a few of you are just doing the logarithms. Today I thought, let's look at a review and a solving, and then we don't actually have to do all of these. We do need to do one of these solving logarithmics, and then we're going to finish the year down here in periodic functions, the unit circle. All right? And then we're done, and in some cases you'll be done with your math career, because Algebra 2 is the last math class you have to take according to the state of Washington. Alright, let's do a review question here. We did 1 and 2. Always a fear of clicking on the video here and not knowing what we're going to find. Determine whether the table represents a linear or exponential function. Okay, now depending on who your teacher was, you have this common ratio, common difference. Common ratio, common difference. So let's click on question help, view. Is there a common difference between the x values? Well, the common difference is right here. Boom, boom, boom. 5, 5, 5. If you subtract one from the other, you see how it grows 5 every time? Well, that's a linear function. Okay? So common difference. Common difference on the x values, add 1, add 1, add 1, add 1. Then each one is a value of 5. Each one is a value of 5. Okay, so the common difference is 5 on each of the y values. Therefore, we have a linear function. Okay, so here 5 plus 4, 9 plus 4, 13 plus 4. All the x values have a common difference. Add 1, add 1, add 1. All the y values have a, not ratio, common difference. Exponential, linear. All the x values have a common difference. 1, 1, 1, 1, 1. And all the y values have a common difference. So we'll click, whoop, don't do that. Don't do that. There we go. Okay, then we got to make it wider. We got to check our answer. Okay, so hopefully that was helpful. 2 raised to the 2x, that's just a growth curve, right? It's just going to grow twice as fast as 2 to the x, so it has to be something like this. Okay, again, you've got the question help if you need it. Okay, so now it's a growth function, it's bigger than 1. Okay, all right, let's save this. So that was our review. Okay, solving logarithmics. Let's just check one out here. Okay, how would we solve? Be sure to reject any x value given the exact answer. Log base 7 of x equals 2. Well, this is one of those where we got to go to our cheat sheet and translate. We're in this form to solve for x, but the x is the actual answer. So in this case, I forgot to turn my whiteboard on. Sorry. Okay, so we're going to translate backwards. 7 to the 2. Okay, so we're going to translate this. The 7 goes here. The 2 goes here. 7 to the 2 power. What's 7 to the 2 power? 49, right? Okay, so now, let's see here. Let's go to a new whiteboard. All right. So translate. If we translate from log 7 to the x equals 2 back into the form that we grew up with, b to the x equals a, we'll have 7 to the 2 power equals x. So our answer is 49. Okay, so log base 7 of 49 is 2. And for those of you that have the fancy calculator, we can check our work. In other words, what exponent do you raise the 7 to get 49? Second, math. No. Math? Yeah, math. Just hit math. Toggle, log base. Put 7, 49, 2. All right, so now shrink it, 49 it, check it, okay? And these are all similar type problems, okay? 3 to the negative 4 equals x. 3 to the negative 4 equals x. 3 to the negative 4 equals x. So how did I get that? Log base 3 of x equals negative 4. So in other words, what number does this satisfy? Well, let's try to do this off the top of our head. Bring that downstairs to make it a positive exponent. 3 to the 4th power, 3 to the 4th power, 3 times 3 times 3 times 3. 9 times 3 times 3. 27 times 3. 81. 1 over 81. Let's try it. Type an exact answer or simplified form. 1 over 81. Cool. All right. So you can see you're going back and forth with these. Next week, I want to do a couple of, now we don't need to estimate. Properties of logarithms. Properties of logarithms are these, where you can translate and expand and subtract based on these identities. You don't have to do that. Change a base formula if you want. You don't have to do that. Taking a log of both sides of an equation. Solving logarithmic Solving logarithmic equations, part 2. Let's do this one first. Let's see what this looks like. Oh, yeah. 3 to the x equals 27. Cool. Alright. So what this means is the following. 3 to what exponent, right? 3 to what exponent? So now we could do this. 3 to the x equals 27. Translate log base 3 of 27 equals the x. And you could use a calculator. Or, if we take the log of both sides, that allows the exponent to fly outside. X log 3 equals log 27. Remember, by taking a logarithm, we're able to isolate the exponent. Now divide both sides by the log of 3. Divide both sides by the log of 3. Okay? And x is going to equal. So I'm going to do this one first, this one second, and watch we'll get the same answer. Okay? Let's do that. Get me out of the way. Log 27 close divide by log 3 close. Boom. Now, math. Log base 3 of 27 equals 3. Okay? So our answer is 3. And some of you probably didn't even need to do this because 3 to what exponent is 27? 3. All right. So we'll spend more time on that next week. But we're just wrapping up logarithms. So get a hold of me if you haven't quite got to that point, but we're done with the cube root. Most of you have done plenty there. And the radicals. We're into exponents, and we're working through logarithms. Okay? So have a great week. Happy May. Next stop, Memorial Day. Bye-bye.